Good morning. Hi. My name is Mark Reinhold. I work on Java. I'm here today to talk about Java 9 and in particular the module system that we've been working on for a while now and which we hope actually to ship in this release. So this is Make Way for Modules. So in Java 9 we are aiming to introduce a module system. We're going to use that. We're going to apply that module system to the platform itself, to chop it up into pieces, and also make it available for everybody else to use in their own applications over time. Now, why are we doing this? This is a big change. It's a disruptive change. What problems does this help us solve? Well, one is that Java SE, the JDK, is this big monolithic thing. From the beginning of time, at the beginning of time, it was actually reasonably small, but we added features and more new stuff and more new stuff and more new stuff, and now it's big, and it's great that it has so much stuff in it. It's a great toolbox to have, but if you want any of it, you have to have all of it. And this is a problem. It's a problem for small devices. Right, lots of small devices, and this has been true for some years now. They have processors that can actually run an SE class virtual machine, but they don't necessarily have the memory to carry around, the entire JDK or the entire JRE, nor do they have the memory bandwidth to deal with that. A bit oddly, it's also a problem for big machines. Right, in the cloud, but buzzword of this decade, in the cloud, density is extremely important. Even if you've got a big machine, you want to be able to load as many instances of whether it's Docker containers or some other containerization technology. You want to load as many as you can, and if everyone has an entire JDK in it, well, that winds up being a fair amount of space, and it's just wasteful. So today, with SE8, the JRE clocks in at 55 megabytes, and this is for a stripped down Linux 32-bit ARM build. In Java 8, we introduced this notion of compact profiles. These were kind of a baby step towards having a modular platform. So compact profiles introduce layers. It's kind of like the layers of an onion. The compact 1 profile contains the core of the system and maybe a little bit more. That's 11 megabytes for Linux ARM32. Compact 2 adds some additional functionality. You get JDBC and some basic XML stuff. Compact 3 adds more, but it still excludes things like swing at AWT and 2D. And the JRE, of course, is still the JRE, and it contains everything. So compact profiles help, but they're not flexible enough. If your application needs everything in Compact 1 plus one API that's in the JRE, then you're stuck with 55 megabytes instead of 11 or 12 or 13 or something like that. Another class of issues we're trying to address is performance. The JDK is this big monolithic thing. The fact that there are no boundaries between subsystems make it difficult to optimize sometimes, because you have to be prepared for any subsystem to be able to talk to any other subsystem, and that can get in the way. An additional thing is peak performance is generally very good with Java these days, but startup performance is still, as we know, a bit of a problem. And even in cloud-type situations, startup performance is an important thing. You want to be able to take a Docker container and spin it up very quickly. If there's a JVM inside it, get that run up very quickly and get going. And if you have to wait even half a second, if you're talking about a very large deployment, that can be an issue. Another category of problems we'd like to address is that of security. A few years ago, Java went through a period of basically a lot of technical debt showed up all at once in the form of security vulnerabilities, some of which had actually been around for a while. So anything we can do to improve security is pretty much worth doing. Let me just give you a quick example. If we look at all of the packages in, I think these are all of the packages in the Compact 1 profile, Many of these, are meant for public consumption. All the ones that start with Java, right? Those are parts of the official platform, and of course, people should use those. Java, JavaX, and then there's some other stuff. There's some JDK specific APIs. There are all these things that start with Sun that are really internal implementation details. Nobody is meant to use those. The problem is some of the stuff in these private packages is extremely powerful and dangerous. In the famous sun.misc package, sun.misc.unsafe, you can peek and poke any memory address you'd like. Is that something that we want untrusted code to be able to invoke? Well, no, of course it's not. The problem is, with Java as it stood in 1.0 and as it has been ever since, preventing unprivileged user code from going and using internal APIs has been very, very difficult. If you're running with a security manager in, say, an app server or an applet or a Java Web Start environment, we can do this, but it's pretty brittle. The way we do this is with a method in the security manager class called check package access. What check package access does is it looks at the invoking thread, does some tests to figure out, is this thread allowed to access this class in this package? Well, guess what? If you forget to invoke check package access just once in the entire implementation of the platform, you've got a security vulnerability that someone could probably drive a truck through if they wanted to. And yes, this has happened. So we need a better way to isolate internal APIs to keep unprivileged, untrusted code from using them. Related to this is all these internal things, whether they're sun.star or something internal star, they're internal, and we've gotten ourselves into a bad situation where there are some very popular libraries, there are some important applications that use these internal APIs. And this is a problem for those of us who maintain the JDK or other implementations of the Java SE platform. It means we can't change this stuff without affecting lots and lots of user code. So we'd like to get away from this over time, and that's also part of the plan. A final problem area we're trying to address with the module system is the class path. So with the class path, this is the mechanism we have had for 20 years for assembling applications. How does the class path work? Well, you list a bunch of jar files on it. Is there any kind of consistency checking, integrity checking? No. Well, we all know all the nasty things that can happen, and I've seen, I'm sure many of you have seen in production. You look at a class path that has sort of accreted over time, and you find 3 different versions of some logging framework and 2 different versions of Google Guava and a version and half of Apache Commons Lang or something. It's just wow! It's amazing that this even works. Right? There's no detection of duplicates. There's no detection of conflicts. If you get you can get an older version of a library in front of a newer version of the library, and you get some weird mixture of code that is it's incredibly difficult to diagnose failure. So basically, there's no reliable configuration with the class path. Because of that, we've built up tools that help somewhat. Tools like Maven, Ivy, Gradle, they do dependency analysis at build time and help you construct a class path that makes sense. But even those are fairly limited, and they're really only a solution for build time. So we'd like to get rid of class path. Not that we're going to take it away, we'd like to provide an alternative so that eventually people can just move away. So big problem is we've got this. What we want is this. Right, we want a system that's more like a box of Legos, that you can pick and choose the ones that you need. You can make your own Legos that plug in to build just the system that you want. So this is what we've been doing in the Jigsaw project in OpenJDK. This project has been going on for a while, and I'd like to give you a sort of a quickie status report on where we are. So in OpenJDK, as you might know, big units of work are described in things called JEPs, which is an abbreviation for JDK Enhancement Proposal. So it's not a JSR, but it's the sort of thing that can feed into a JSR in the Java community process, if and when that's relevant. So Jigsaw is divided into 4 JEPs. JEP 200 defines the modular structure of the JDK. JEP 201 was about restructuring all of our source code. JEP 220 is redefining what the runtime images look like. And a JEP that doesn't quite exist yet, but we do have a JSR, is for the module system itself. And all of this is going on. You can go find this URL or just search for it, and you can get more information. So what does the modular JDK look like? Thankfully, it does not look like this, but this is where we started. So at the very, sort of almost at the top here is the base module. The base module is the one module that you always have to have. It's kind of the Java-lang object of modules. In fact, it contains Java-lang object. So you can't live without the base module. Every module implicitly depends on it. This is where we started about 5 years ago when we began the process of carving up this monolithic code base. It's kind of a mess. What we did was figure out generally functional areas that we thought deserved to have their own module, and then we did static analysis and also a little bit of dynamic analysis to figure out, well, what are all the dependencies? And it turns out well, as you can see, it's kind of ugly. So if you always have to have the base module, then one question to ask about this graph is, well, is there anything, does the base module depend on anything? And in fact, if you take the transitive closure of the base module, you get, you get most of the other modules. So if all you want to do is print hello world, you're going to be carrying around Corba and logging and JAX-P parsers and JAX-WS just for hello world, because this is the challenge that we had, because in principle, right, the base module shouldn't depend on any other one, right? You should be able to use just the base module and nothing else. So we did a bunch of work. Most of this was done by my colleagues Alan Bateman and Mandy Chung at Oracle. And we eventually, over time, we eliminated a bunch of these edges. We refactored the module definitions and got to something that we think makes a lot more sense. Now, this still, I know, is a bit of an eye chart. Let me walk you through it. So at the bottom here is the base module. There are arrows coming in. There are no arrows going out. Good. Success achieved. For everything else here, things that are in orange, well, actually, things that are in orange implicitly have Java dot in front of them because they'll be proposed to be part of the Java SE9 standard. But if I put Java dot in front of them, then I have to use a font that's much smaller and harder to read. So imagine all the orange things have Java dot in front of them. So we have base. For compatibility, we have modules that correspond to Compact 1, Compact 2, and Compact 3, the profiles, but those are there just for convenience for anybody who did use the Compact profiles. Otherwise, what we have is a fairly clean functional division. So there's base, logging depends on base, scripting depends on base. Lots of things, it turns out, depend on logging. There's a color coding on these edges too. If there's a blue edge, that means that there's an API dependence that, let's see, SQL, for example, its API depends on classes and interfaces defined in the logging module, and we'll see more details on this in a minute. If it's a gray edge, then it's just an implementation dependence. Okay, so we've got all the orange things. At the very top of the orange pile is the java.se module. So if you really want all of Java SE9, you can ask for the Java SE module, and you will get all of Java SE9. And since that's part of the standard, that will be true for any implementation that you might use. Now, the blue modules are modules that are specific to the JDK. Other implementations may or may not have them. Some of them are defined service providers, like the care set service providers for for less common character sets, things like the HTTP server, the Java-C compiler, JavaDoc, other tools, XML web services binding. What else is interesting here? Right, a lot of these are also service providers for crypto and things like that. And various tools, JVM, Stat, JConsole, hotspot agents, and so forth. So the blue things are beyond the scope of the standard, but will show up in the collection of modules that make up the JDK. Okay. All right, we have a bunch of modules. What can we do with them? What can we do with them that's new relative to what we can do today with the monolithic JDK? Well, one thing we can do is answer a question that I asked when I started working on Java almost 20 years ago. Does Java have a linker? I asked this question of James Gosling. He's like, no, Java doesn't need a linker. Well, actually, we're going to make a linker for Java. Why would we need a linker? Well, here's what we can do with a linker. The idea of linking in Java is now going to be, well, you have dynamic linking. We've always had that. Let's introduce an optional static linking step. If we can take modules, whether they're jar files acting as modules or modules in a new format that we're introducing called JMod, run them through a linker and produce a custom Java runtime image. And that runtime image, it looks pretty much like a normal one, but it only has the modules that your application needs. And maybe, as a convenience, it even has a launcher that's just for your app. So you can package up an app in one bundle. It contains the virtual machine, contains the runtime libraries that you need, but none of the stuff that you don't. Of course, modules are also useful at compile time and runtime, and an important part of our overall approach is we're trying to define a module system that has fidelity across all phases. So you have modules at compile time. You'll get compile time errors if you do things that, for example, attempt to cross module boundaries. You have modules at link time, and you have modules at runtime. So even if you have old code, if it tries to cross a module boundary at runtime in Java 9, you will get an exception, and I'll show that later on. Okay, all this talk about modules, graphs of modules, linker tools. How do we actually think about modules? What's the conceptual language we want to use for describing them? So let's look at an example. Here's the java.base module. It actually has a ton of stuff in it, but I'm only going to show you a little bit. Among other things, it has the java.lang package, of course. Over here, we've got the java.sql module. It contains the java.sql and javax.sql packages. And of course, java.sql is going to wind up depending on java.base because, well, every module depends on java.base. Inside java.sql, let's go look at some code. There's a connection interface, and it's going to reference JavaLang string. Surprise, surprise. Well, as things stand now, will this even work? Well, the answer is no. It won't work at compile time. It won't work at runtime because I haven't explained how to get the java.lang package exported by java.base. By default, if a package is in a module, it's just inside the module, and you have to declare that you want it to be used by other modules in order for that to happen. So without getting into syntax, bike shedding, or anything, I'm just going to go with a visual notation. We stick an asterisk here. That means we're going to publish this package for use by any other module. And so now the SQL module, it depends on the base module, and it gets all of the types, all the classes and interfaces in the java.lang package for use. Okay, that problem solved. What else? Well, java.sql, that package, of course, also needs to be available to other code, in fact, all user code. And so the same is true of javax.sql, so we'll put asterisks on those guys too to say that these are exported. There's some other code in java.sql that uses some internal APIs in the sun.reflect package, the color-sensitive annotation and the reflection class. And sun.reflect, it's inside java.base, but, well, it's not exported by java.base. So it's there. We could put an asterisk on this, but would that be a good idea? No, because that would make this available to everybody, just like it is now, which is a problem. So what we want is to get this package exported only to java.sql. This is a bit like friends in C++. So we'll use this notation to mean that the SQL module can access this package, but no other module can. Okay, there's some other code in the SQL module. That in the driver class, it turns out there's a method called getParentLogger, which will return you a Java util logging logger. I know, everybody's favorite logging API. Anyway, there it is. So the SQL module obviously will have to depend on the logging module. The logging module will need to export the Java util logging package for everybody to use. That way the SQL module gets it. And of course the logging module uses the java.lang package and lots of other stuff in the base module. Turns out the logging module also needs sun.reflect, so we can have a list of modules to which this package is specifically exported. Okay, one more thing. We have an app. It has a package, confu app. It will depend on java.base. It gets java.lang. Of course, it cannot access anything in sun.reflect. Confu app is going to use the SQL module. The SQL module will export java.sql and the java x.sql packages to it because we have asterisks here. But then if in confu app there's code that uses that getParentLogger method, right? Get a driver, open a connection to whatever your database URI is, and then get this parent logger and log some helpful, informative message. Is this going to work? Anybody? Bueller? Yeah? No? What? No, it won't. The reason it won't is that, well, where is this method? This method is over in the logging module, right? It's in the Java util logging package, but the app module isn't reading that. It has no dependence on it. So we could require that the app declare that dependence itself, but that doesn't really scale very well. What you want is a way in the SQL module to say, this module exports types that have types from that other module over there. So if a module depends on me, make it depend on that other guy too. So this is an implied dependence. Because app depends on java.sql, it magically gets a dependence on the logging module, and then method chaining like this will work the way you want it to. Last but not least, there are lots and lots of packages in the base module. Sun.invoke is just an example of one that happily is not exported anywhere else. So it's hidden behind a concrete wall. All right. So that's the general conceptual approach. What's the impact? Well, there's no gain without pain. Let's talk about some of the pain. So in JEP 201, we introduced modular source code. This change affects not that many people. In fact, it really only affects those of us who spend our life working on the JDK. This was a change to the structure of the source code. It was dramatic for those of us who live in this code, pretty much invisible to everyone else. And we got this done back in August. JEP 220, modular runtime images, was definitely more dramatic. So the structure of the runtime images today, and this has been the structure since 1.2, we've changed fairly dramatically. So there's still a bin directory that has commands in it. There's still a lib directory that's got internal stuff in it. But we've changed the lib directory so that nothing in it is meant to be modified by users. Things like configuration files, security properties, and other stuff is now in this conf directory. So if it's in conf, You can edit it. If you go editing something in lib, you're probably asking for trouble. Among other things, we removed the endorsed directory, the ext directory, and rt.jar is gone. Now, some people have taken that to mean, oh, you're killing jar files. Jar files won't be supported anymore. And nothing could be further from the truth. All this change means is we are not using jar files internally in the JDK itself anymore, because jar files are pretty much the worst possible format you could choose for that purpose. What we have hiding behind these three dots here is a brand new, completely internal, highly optimized storage format for classes and other internal data for the JDK. We are not, that format is not going to be standard. It's going to be very thinly documented. We will change it if we need to in update releases. It is not meant for external use. So there's some interesting design stuff in it, but it's really not for external use. Okay, so those changes went in a while back. Oh, and there are some really fun compatibility issues with this change. Does anybody know what this method would return if you invoked it with that string? I'll give you a hint. The type is java.net.url. Sorry? A file path. You're close. Okay, what you get back is a jar file URL. Who knew that there were jar file URLs? A fairly obscure corner, oh good, of the JDK. So a jar file URL wraps a file URL, so you were on the right track, and then indicates some particular entry in the jar file. So no surprise, there's code out there that depends on this sort of thing working. Happily, the specification does not require that this be a jar file URL. It just requires that it be a URL that you can open. So what we did was we defined a new URL scheme called JRT, which is short for Java Runtime. So JRT, java.base, is the module name, and then the path to the specific resource in there. And so it's a fake URL scheme. It's not IANE standard or anything, but this is interpreted within the JDK. So you can get a URL for an internal resource, and then later open it, pass it around to existing legacy APIs that want URLs. Another thing we did was we created an internal NIO virtual file system for accessing internal resources. The biggest impact of removing rt.jar is, well, every IDE uses rt.jar to discover stuff about the internals of the JDK for which you're developing code. So we needed to provide an alternative to that. For that, we made this fake NIO file system that you can go explore like any other file system. It's indexed by both modules and by packages if you need to get something by packages, and that way you can read resources for anything that's inside. Okay. When we introduced the actual module system, and we actually have this working in prototype, access to internal APIs will no longer be there by default. So they say every technical talk should have a call to action. Here's my call to action. We have a tool. We actually shipped this in JDK 8 called JDEPs. It's in the bin directory, and if you run it with the -JDK internals flag on random application jar, library jar, whatever, it will go do a static analysis of the code and print out warnings if you are using internal APIs. So, number one thing you can do to prepare for 9, which is still a ways off, is go run this on your code, on your own code, on libraries that you use, to figure out, do you have any known or perhaps unknown dependencies on internal APIs, and formulate a plan for getting away from them. Now, there will be workarounds. There will be ways to continue using internal APIs in the 9 timeframe, but they won't be very pretty. Okay, so that's Project Jigsaw, quick status report. Now if I can get the right thing to work, we can do a little demo. Okay. Press the button, and voila. Okay, so I've got a few things set up here. Here's Confu app. It's got a module definition and a main class, which doesn't do very much. It says, hello, modular world, woo! Let me compile that. So I'm going to compile that into this mods directory. Now if I look in mods, Confu app, there's this same module info.class is the module description, and then the class file is down there. I can run this just by this is just an exploded classes directory that happens to have some module information in it. That'll work just fine. More interestingly, I can package this up. So let me do that. No, I don't need help. I need this. So we've enhanced the jar command, the jar tool, to support a notion of modular jar files. So we could define a completely new packaging format for modules, and in fact we will, at least for the purpose of shipping the modules that make up the JDK, because they have native code and other gunk in them. But for pure Java things, we want to allow jar files to continue to be the default format. For shipping code around, jar files aren't great, but they're okay, and everybody understands them. Every tool understands them. So we can create a modular jar from what we just compiled by saying jar-create. I'm just using the long forms of the options. There's the archive. We can specify an entry point. Confu app.main contains our public static void main method, and then we just package that up. And if I look at what's in there, looks like a jar file. It's got this extra module info.class thing in it. But otherwise, if you could stick this on a Java 8 class path, and it would work, right? The module information would just be ignored. But if you use it as a module with Java 9, then it will be treated as a module and have encapsulated and be encapsulated and have its dependencies and everything else taken care of. All right, so let's run this guy. No, I don't want to show you that yet. Relying too much on history. Okay, so in addition to the class path, we have a thing called a module path. A module path is, unlike the class path, it's not a sequence of actual modules, it's a sequence of directories containing module artifacts. So mlib is where I left that packaged up jar. I can say java-module path mlib-m means go run this module confu app, and there we go. I can ask, what are the modules that you loaded in order to run my app, by saying list mods. Now, confu app, you might think only, well, actually, confu app corresponds to what I was showing earlier. It depends on SQL and XML. But oh my goodness, why are there all these modules? Now, at least that's not all the modules, but that's more than you might have expected. The reason for that is because some modules get pulled in because they're service providers, and then the service providers depend on other modules that also get pulled in. But if we really want to work with a minimal set, then we can limit this to just the modules that we know confu app needs. And there we get to what we expected. So we've got the confu app module itself, which is in this jar file, Java base, Java logging, Java SQL, Java XML. And that's it. Okay. Let me show you the linker. Whoop. So with the linker, I can make a custom runtime image. Here, I'm going to give it the module path. I also have to tell it where to find the modules for the JDK. Those are here. One of the deliverables in JDK 9 will be a directory full of module artifacts. These are in this JMod format, which is, it's not the jar format because it's extended. It can handle native code and configuration files and licenses and other stuff. But you can think of it as a jar files on steroids. There's one of these for every module in the JDK. So if we're going to make a custom image, we have to have those in addition to the modules that we're actually going to package up. Okay, so there's my JLink command. I'm going to tell it the module path is my mlib, has the confu app module in it, as well as all these things in $mods. I'm going to limit mods to just what confu app needs. I'm going to add confu app and nothing else, and I'm going to put that output in the image directory. It does a little bit of work, and now I have an image. Ooh, what's in here? Image bin. I have a launcher for confu app. I also have the usual Java launcher, and I have key tool, and I think that's a bug, but whatever. In the lib directory, we've got some internal things. There's lib amd64, has the VM in it. Lib modules has the secret internal optimized JImage format. And conf has configuration files for logging and networking and security. So if I go look at image bin again, I can go image bin java confu app, and oh, it runs my app. If I do a list mods without specifying any module to run, these are all of the modules there. There are no others in this image at all. I can even get more details if I want to see everything there is to know about confu app here. Well, it requires java.base, it requires java.sql, and it conceals confu app. And then, of course, I can also I can just run this command directly with the launcher that's provided and is running off the bottom of the screen. So I'll run that again. Ta-da. Okay, so that's the linker in a nutshell. Packaging up a module, linking it together, making a custom image. The other thing I'd like to demo quickly is the access control, the protection of encapsulation boundaries across modules. So let's look at a little bit of code. Whoop. Okay, test one, import sun reflect reflection, one of those nasty internal packages, and it prints out the caller class of whatever it is that invokes main. So if I run this on Java 9, or sorry, on an 8 or earlier, this works. If I run this with my default Java, which is a very fresh build of the Jigsaw prototype, it will fail. Exception in thread main, Java lang, illegal access error, class test 1 in the unnamed module cannot access sunReflect reflection because sunReflect is not exported to the unnamed module. The unnamed module is a special module that's used for code that comes in on the class path. So you might think, well, okay, you can do the trick you usually do, use reflection to get around that, right? Okay, so we'll go to reflection. We compile that. Will it work? No, it will not. Illegal access exception with pretty much the same error message. You move up the bottom of this. You might also think, oh, well, okay, I can't use normal reflection. I know, I'll use method handles, right? So you could try this with method handles, and guess what? We got that case too. So in Java 9, internal packages of modules will be encapsulated. Access to them will be controlled by the VM at a very deep level. Almost the same logic that keeps private methods and fields private is going to keep private packages internal to a module. So this will impact a lot of existing code. Some people have expressed concern about this. We aren't going to leave you completely high and dry. There will be a way to get around this. It won't be pretty. Let me show you. you can use the magic X flag, -X add exports. Base and .reflect and run test one. So what this is saying is start up the VM, instruct the VM to behave as if the base module exports sun.reflect to the code that's on the class path. And that will work. Null is actually the correct answer. So if you have a system today that depends on sun.reflect or sun.misc unsafe or something else, you will be able to make that code run on 9. The price is you'll need to go figure out which xadd exports flags you need to add to your command line. The JDups tool can help with that. The error messages that I showed, we've tried to put as much information in them as we can to help you diagnose situations where you need to add some of these exports to keep a system running. Okay, that's the end of the demo. There appear to be 7 minutes left for questions. We can try the fancy new app. You can also just tweet at me, and I can read those. So, question? Yeah.
About the redistribution.
Hang on. I think let's do this for the recording. Is this on? Thank you.
I have a question.
That's not on.
Maybe you can just turn it on. It's about the redistribution of the custom images you can generate. We will be able to.
Sorry, I can't even hear you. Since that's not working, here, stand right there.
Hello, thank you for a great talk.
No, you don't need to flatter me. Just ask the question.
Okay. It's about the redistribution of the custom images you can generate. Will they have licensing issues, both in the Java SE environment and the Java embedded environment?
You would have that's a legal question. You would have to consult your attorney and interpret whatever license your vendor is supplying. I don't know exactly what the terms will be for Oracle's JDK, but I think the right thing will certainly be that you can redistribute it in all the ways that you can redistribute it now. But
questions?
Will the module system be interoperable with OSGI?
yes and no. Not really. There's interoperable and there's interoperation. So it's always been a goal of Jigsaw to make sure it's not a goal, it's a constraint. OSGI has to be able to run on top. That has to be workable. We also intend to provide ways for an enhanced OSGI implementation could interpret Java module information and make use of that in the OSGI way if it wants to. But we're not adopting OSGI for a whole bunch of reasons that I could happy to go into offline. But there will be a certain level of interoperation. Question on Twitter. In your demo, the illegal access exception was thrown at runtime. Is there any way to anticipate of compile time? Yes, absolutely. Right. Remember, this is the whole fidelity story. The examples that I showed you, those little test1, test2, test3.java, I had to compile those with Java 8. Because if I compile them with Java 9, I would get compile time versions of the exact same errors. And maybe I should have showed that to you to drive that particular point home. But we're trying as much as possible to have the same behavior at compile time and at runtime.
Hi, Mark. Where does in your slides you have a desktop module?
Yes.
So where does the older AWT and JavaFX modules go? Are they separate modules or?
So AWT is in the desktop module. The desktop module is one of the bigger modules. It contains AWT and Swing and 2D. It would have been really nice if we could have an AWT module and a Swing module and a 2D module, and we tried that and wound up losing hair over it, so we stopped. Those are all one thing. JavaFX in Oracle's JDK binaries will be its own small set of modules. We're working with the FX team. We've got it, I think it's like between 3 and 5 modules, depending on whether you want WebKit or not, and some basic choices like that. So FX will be in modules too.
Will it be possible to pack custom image which will be cross-platform with native code? Like have one image for Mac, Linux, and Windows?
No. Well, I mean, it's possible. Are we going to do it? No. Yeah, the fat binaries, you could argue about all day. Another question from Twitter. Mark is not using the JDK 9 early access released by Oracle in his presentation. Well, no, of course not. I'm showing you the Jigsaw prototype. But that does remind me to let you know. If you go to jdk9.java.net, dial now, jdk9.java.net, you can get JDK 9 builds that have all the modular image changes. They don't have the module system yet. That will come hopefully in a few months. But if you want to get a taste of what life is like without rt.jar, those have been in the JDK 9 builds since December. We do intend to ship some Jigsaw-specific early access builds early this summer. So if you're interested, keep an eye out on this page, and we'll be announcing it in email and social media, whatever. Okay.
If I've got libraries that use native code in some way, like JNA, for example, or some of the JDBC drivers, can I use JLink to generate a deployable unit that I can share around using that, which will have the .sos available or the DLLs and added to the path?
Yes, the JMod format we will make available as a format that's supported by the JDK. I don't think it'll be part of the SE9 standard, but it'll be there and supported. And if you want to have a library that has native code in it, you're welcome to use JMods. Oh, thanks. M. Reinhold's voice is very calming.
Yeah, hello.
I do my best.
We've seen two diagrams about showing the module structure before and after, and I've noticed there is no dependency on the logging inside the base. Does it mean there is no need for logging inside base or?
Excellent question. There is some code in the base module that does logging. We thought it was a bad idea for logging to be stuck in there because, well, maybe someday we want to get rid of it. So we did a little bit of magic so that the little bit of logging that's done inside the base module, if you don't have the logging module, it just prints the standard error. If you do have the logging module, then it routes through the logging module. That's an example of one of the catalog of tricks we developed to get from the really complicated graph that we started with to the simpler graph with which we ended. The screen is blinking red at me, so I guess that means I could stop. Or
can I ask the second question?
Do a couple more questions. I am at the mercy of the court.
Yeah, the second, I also noticed there is a removal of the external directory inside Java, and there is some internationalization for support for locale. You could use external libraries and enhance your local to enhance the available locales in JDK. How this problem is going to be solved in the next version?
Services. So services are another key tool in coming up with a clean module graph. We've had services in the JDK for a long time. They were introduced as a convention way back in 1.3. We introduced the service loader API in 6, and we're leveraging that for modules. And in fact, a module can declare that it provides certain services, that it requires certain services, and that's all part of the module configuration and resolution process. So for things like locales, the way those get hooked in is you have a module that declares this module provides the locale, another instance of the locale service, and the service binding algorithm will go find it. And that's how things like that get hooked up now.
Last question.
No more questions? Okay, quick skim of Twitter. I'm sorry, I didn't try the app at all. Oh well. Okay, well, I guess that's it. Thank you very much. If you have any questions, I'll be around the Oracle booth all day. Thanks.